All right. Thank you for joining this session, guys. Very grateful in terms of seeing the support and in terms of adhering to the attendance here. I apologize, we are starting late, but we are accustomed to join meetings late more often. But let's get started. My name is Sohail Adnan, and I have over 12 years of experience associated with IT and technology for last 12 years, been at various level, at various designation. Um, think of me like one of you, where you have started your career. I have started my career too. Absolutely L0, that is where I begin my career from. And throughout the 12 years of journey, I have been at various places, could be L1, L2, and L3, could be an SME, solution architect, DevOps engineer, um, security specialist, right? And now I'm associated with RIA Infotech, and I'm responsible to drive innovation here uh, uh, around cloud and security. And today we're going to talk about a mix of cloud and security and how DevSecOps is helping organizations to achieve more, be productive, bring IT closer to their customer. What are the things that they need to cultivate and incorporate in their process? Some of these areas is what we're going to discuss in our presentation today. So sit tight, relax. A quick overview about 3i Infotech. We're a global organization. We have over 5,000 plus employees all over the world. 18 offices we have in 11 countries. We have over 1,000 plus customers with 5 offshore delivery centers. Predominantly one we have in Chennai and one in Bangalore, and one we have in Sharjah also, just for your reference. 3 business lines that we currently support today. I am a part of a service line, but we also have banking and finance, where we design and build BFSI products such as anti-treasury, anti-money laundering, um, mobile banking. We also have a product line around a business application, where we design and build CRM and ERP and other order fulfillment softwares for manufacturing industry. And then I'm a part of a services where we do build and manage on-premise and public cloud data centers for our end customers, and design and build various solutions on top of it. It could be data analytics, it could be agile testing and automation. Today we're talking about DevSecOps, integration and services, migration to the cloud, DR backup. So various portfolios that we have as a holistic that we work with our end customers. But today's agenda is DevSecOps. I'm going to align to that today. So some of our customers, the names and the logos are familiar to you already. In some form, in some shape, we are associated with them. Some we are working in on-premise, some we are working on security, some we are working on cloud, some we are managing the data center. So in various form and shape, we are associated with some of the prestige organizations here in this region. So DevSecOps, what, why, how? So a lot of buzzwords that we are seeing, that DevOps has to move forward from waterfall model to an agile model, and then how do you incorporate security in the process? Where do you start from? What tools to select? Will it be applicable for small development team, or is it only for the large development enterprises that we are looking at? Do I have to pay for a tool? Are the tools are free? Are skill sets available? So the lot of questions that you have, what, why, and how. So we'll try to answer that in my following slides. So the agenda and the takeaway from this webinar is, by the end of the webinar, you will understand what is DevSecOps, why do we need, and how it is important in your development life cycle. How do we do DevSecOps? Tools, process, technologies that you have to bring it in, a culture mind shift that you have to introduce. Those areas that we will figure out. Integrate security in DevOps pipeline. At what stage a security has to be baked in? Does the security come first, in between, or in last, or is it together? So those, how we can marry a development, operation, and security. These areas we will emphasize on. Tools. So since most organizations, specifically after COVID-19, are shifting from on-premise to cloud, Cloud brings their own native tool capability. They have their native tool chains that we would like to embrace in our development process. So I would like to show you a comparison and list of tools that you can make note of, where you can go back and explore and play with these tools in your environment that you have. And a case study that I will discuss with you to ensure that you understand how DevSecOps is solving corporations' problems today. So what is DevSecOps? It's basically three teams working together. One being a development team, the second being an operational team, previously known as DevOps, development and operation. Now we're introducing a third layer, a security team, where a development, security, and operation team, hand in hand, they work together as a single team. So in order to begin this, you have to bring in a set of tool chain. Think of it like a car assembly line. A car will start as an empty hollow shell at the beginning of the assembly line, and by the end of the assembly line, the car is fully built, right? So if this is an analogy that you have, or if you could visualize now, at every stage of this assembly line, a piece of car is put together to complete the car by the end of the assembly line. So think of it, a development team and a security team and an operation team are together on a same assembly line. At every stage, each other are holding their hands eh, to achieve the end goal. And this can be done in form of introducing a list of tool chains. This tool chains can be a development tool where you write your code. It could be a source repository where you store your code. It could be a built engine such as Jenkins where you build your application. It could be then a testing environment where you test. It could be a pen test that you're doing on your code, right? And then you deploy it, whether you deploy it on a container, on a serverless, or as a monolithic application. Then you monitor it, right? And then you track the bugs and you circle back again. So various roles are put together into this assembly line to ensure that the end code or the end product is a bug-free, less vulnerability or no vulnerability at all, performs well and stable. So in order to achieve this, a culture has to be introduced in an organization. If there is no culture of that sort, a culture has to be brought in, a process or a methodology has to be put into a place, a tools has to be introduced which can complement each other or which can fulfill the whole assembly line, and a cross skill new skill improvements has to be done where an internal organization has to upskill or train the resources to ensure that they adapt to new culture, new framework, and then they can use that tool. So why do we need DevSecOps? So typically in a waterfall model, you start your development. A development cycle is anywhere between 12, 18, and 24 months. By the time you complete your development, the requirements is no longer relevant. The requirements have significantly changed by then, right? It's cumbersome. Once the code is developed, then you send it to a testing, and then the testing comes back. It's a time consuming, and the loop back is delayed, right? So you want to expertise that, and therefore you want to ensure that your team is rapidly developing this code, right? From a traditional perspective, from a time-saving perspective. Second is traditional security cannot keep up with it. A new kind of security has to be baked into the code at the beginning of the development of this code. So you can have a small team able to do multiple releases the same day, able to test and come back and revisit that code and recur it accordingly. So rapidability is one example that I would think of that a DevSecOps need today. A second thing is, how do you manage various branches in large projects? So there are more than one developers that are developing it, right? So what code you're writing, did you download this code from some GitHub? Was that code had vulnerability already, or the engineer has already hard coded a secret key and access key in the code that he's going to commit into public directory, and therefore whoever downloads it, he gets the access of your environment, right? Sanity check around it. So all this is important. A controls has to be put into the place, so to ensure that there's a uniformity in terms of how the code is written, what sensitive information that is not passed into the line of the code. This is important. So DevSecOps will try to solve that problem also. Third thing is smooth scalability and process. So you are rest assured that as and when the cloud scales up, the code scales, you are rest assured that where your code is hosted, you can keep track of the vulnerability that is happening on the code because your scan codes are embedded into that. You get those loop feedback, right? So all those information real time you will get. Think of it like a data analytics where all the endpoints you try to manage, map, and collect those data, and you take a decision out of it. Security is also something like that where you have to map all the code endpoints, page endpoints, and see which page is performing what, which page has an injection, which page has a loophole, right? All this data has to be collected and data driven decision can be made within your code, right? So this will ensure that you follow standardization, security is baked into it, and you minimize the surface area. So therefore this DevSecOps is important in your development life cycle. Now shift security to left. So now the security is in the center. You have a development, you have security, and then you have an operation, right? So industry experts, Gartner says, hey, why do you have security in the center? Why don't you move the security to the left? So basically what they're trying to say is, can I merge a security team and a development team together? So can I introduce security early in my development life cycle? So from the time I write an hello world code, that hello world code, can it have some embedded security baked into it already? Can I ensure that there's an encryption already there? There's a wrapper around that I can write, right? Can I do a call? So today we are in an API world where a host of APIs that are available. Just to give an example, Google Map API is available. Today you can develop your application, and for the entire map data of the world, you can just make an API call, and any information that your application passes, the API can go to the Google server, bring that information and show you the wise map. And any restaurant that you want to look, your application can go and make those API calls to Google server and can show you a restaurant within your area. So APIs are available, and from an API perspective that is secure, but from your code perspective, you're not sure what information you're collecting, what information you're sharing, what vulnerability you have. So you want to ensure that from the time you write hello world, you want to bake security into it. So when you say shift security to the left, basically what we are saying is introduce security from day one, even before you're writing the code, right? Bring those processes in place. How do you write? How do you test? How do you analyze? Even before deploying this code to the production. So you will have information early on the bugs that you have. Now, let me give an example. Today, 50% of the codes are not written. It is downloaded from the internet in form of frameworks, in form of libraries, right? In form of pre-written public codes from public repositories. So developers typically download written codes, frameworks, and libraries, and they try to compile. And probably 10 to 15% layer is what they write on top of it, and then say, hey, the software is ready, or the prototype of the software is ready. Now, one thing that you don't understand is 50% of the code in libraries that you download, you may not even use at all, right? It is just there. It is a part of a package. Now imagine those vulnerabilities such as .NET or PHP or Java library that you download that is old in nature, and vulnerabilities are already reported on common vulnerability and exposures website. Developers don't go and check that. So having security from day one will ensure that developers are already aware what vulnerabilities are published on the internet by common vulnerability and exposure database, and they can go back and cross-check with the packages, libraries, and guide you, hey, there's already a vulnerability reported in these packages that you're downloading off of the internet, or libraries that you're downloading is already vulnerable, it has been reported, and therefore it is not recommended that you download constructing your software on top of it. So these are the best case scenarios that I recommend that you calculate security from day one. This will quickly help you out to ensure that you bake hardening from day one. Any errors that you realize later and go back. Nobody wants to do double work, right? You write a code, you go back, and then you get the feedback, and you have to redo the whole thing again. Nobody likes to do that, and it wastes developers' time and effort. It also takes longer time for a developer to deliver the same result, and there's a cost for an organization because you're doing the same thing twice, thrice, and four times, right? So avoiding errors initially, right? And costlier mistakes we can avoid, reduce risk, therefore reduce cost, fewer errors that you can do, and fewer compromisations that you will have when you're writing a piece of code. So there are different thoughts that you could see on the internet. I picked this up from a Wikipedia. So in a layman term, the basic fundamental of DevSecOps is you kind of collaborate all this together, and there's a quality assurance that you have. You know that I have a very good development team. As a business leader, you know that I have an excellent operational team, and then I also have an excellent security team. So there's a peace of mind that an organization, business leaders or project managers will have, because they have best of three that he needs, and he can go back and assure his customer that the quality assurance of the product that has been developed and handed over to them, right? So this is important, that just not DevOps or DevSecOps, make sure that you also have a quality assurance there, and you try to shift that security from middle to the development stage. By shifting it to left, this will ensure that from grounds up you have baked in security into your product. So why should you care about security? If you don't want to be, if your organization doesn't want to be here listed, then you should be considering security. Days are gone where infrastructure was a loophole, where you had to install firewall, you had to install intrusion detection prevention to prevent attackers to come in. So the new world order is application security. It's not infosec, it is appsec. And if you see the names, there are some of the renowned names that you're familiar with, such as Dell, Facebook, Reem. You have Uber, right? Twitter. So T-Mobile, so Ticketfly. So these are some of the renowned names whose environment was hacked through application security was bypassed, and they came into the environment and they created a trouble. Some, for example, Capital One lost hundreds and thousands of customer data, right? So this breach typically happened through application vulnerability. It wasn't through infrastructure, right? So if your organization doesn't want to be here, make sure that you introduce DevSecOps in your process. Security before code written. Two areas that you need to focus at. Don't be in a situation where you write a code and then you hire a pen test or a bug bounty guys or some third party black box, gray box guys and say, hey, I have written the code, go try to do test and tell me where is the loophole. That is not an efficient way of doing that, because the reports are as good as the end guy, his skills and his expertise and the ability for him to automate or program the tool to get the outcome, right? It is completely on his discretion, and there's a huge human error, and there is a gap in terms of what reports that are generated and handed over to you, right? So we always believe that the third party consultant can do a great job. I'm afraid not. They're also human, they're also having a limited knowledge, and they can only do so much, right? So instead of taking a traditional way of getting your code tested through pen testing methodology or gray black box approach, I would strongly suggest that you proactively think and introduce a think process here that ensures that the architecture and security designs are best in class, right? All the threat intelligence you have already in advance, and therefore you decisively say, hey, I do not want raw code or a random code, or I don't want to use any pre-written pre-populated form framework that are there on the internet, but instead I will only write what is relevant to me. Instead of downloading hundreds and thousands of lines of code that you're never gonna use it, you try to write a clean sheet of code, put a architectural framework there, see what features that are needed, and only write what is needed. So it will be easy for you because it is you who has written the code. You have not downloaded this from anywhere else. So make sure that you calculate this. Security, you make sure that from day one you put all the controls in check, that nothing is hard coded. Nobody's hard coding access key, secret key of AWS or Azure there, right? Or nobody's hard coding Google Maps username and password there, right? So this ensures that you do not pass any information within the application, right? And third thing is you timely analyze your application. Do not keep your application to be deployed and then tested, right? So the moment it is built, put it to a test and the test results comes back, you can go back and revisit and you can work on that, right? And create an operating procedure so that you can reuse the code that has been tested before, and no bugs or without bugs or bug free. Try to reuse that code as an operating procedure. This will significantly save development's time and testing time also, right? Uh, Legacy security practice, right? We do threat analysis. We try to go back and see what is common vulnerability and exposure website is talking about. We go to Osawa, we see, okay, what is open web application pen testing data that they have published there. What are the top 10 problems that they have listed there? You go back and check it, try to gather that threat intelligent, and you kind of come back with a system design and say, hey, this will be a serverless application. This will be running on microservices. This will be a monolithic application. I'm going to use a .NET versus PHP versus Java or Python or something else. And database, you will identify it as Oracle or MS SQL, or it is a NoSQL database that you want to use. So all those system design work that you will do, and then implementation that you will see, okay, will this be a monolithic approach as a single stack that I'm going to build? or I want to microservice it, right? And then you start testing static code analysis that you do, right? Static is basically a mundane tool. So when you run a static application security testing tool, it'll give you a 900-page report. And trust me, it is difficult to decode and understand. And you may have to go through several iterations of training this tool to find actual problem, right? So there's a huge learning curve. And sometimes you can work with a vendor who has already passed this learning curve and has runbooks and automations to do this. But again, it is static in nature. It's a great candidate if an internal team is doing this, not an external team, right? And after that, you will use infrastructure analysis tool to test, okay, if my ports are opened, is there's a runtime behavior problem that I have in my operating system, is my OS is hardened there, how is my middleware configured. You will do one round of configuration from a networking perspective, what ports are open, not open, and finally you will try to encrypt the volume within the operating system by encrypting the storage where the code is stored, and probably will also install an SSL certificate to make sure that the whole tunnel is also encrypted. And finally, a pen testing will come and do the test. So this is a typical legacy model that we follow. But in security best practices, it is so the whole assembly line model is now twist and bended. So basically, what you are creating a loop back around each segment here. Now, if you see, there are two loops that you're looking at. Instead of having one continuous loop, in some presentations you may have seen there's one continuous loop like a circle where the whole cycle is circled back and again and again. And some will use two loops and some will use three loops. So basically, what this loops means is from where you start from, you don't have to end there. You can probably end somewhere in between, realize that this is not what you want to achieve as a result, and even before you complete the loop, you go back and you start over again. So this will significantly reduce your time, and the other set of loop teammates that they can focus on what is important to them. The whole thing doesn't have to go back to the loop. So efficiently using the end team's time is also important here. So if you see in this loop, it is segregated into two areas. One is a developer writes a code, it gets built, it gets tested, and the code gets released, right? And in the release, the features that you have asked for, is if the features are not there, or you have a plan feature, you can send back to planning stage and you can replan the code, rewrite something that is needed, maybe an integration with Facebook for an example, and then you can cycle back again, right? Or if you think the plan is met and everything that is needed is already there, you release it, you go to a deployment, and once it is deployed on container or on monolithic VM or on serverless, you operate that, you monitor that. So this is one infrastructure cycle that you're looking at. But during this process, when you're shifting to the left, what you do is you first check in, you do static analysis, right? During the phase of build only, you'll do static analysis, and then you do static application security testing on top of it, right? Is it meeting my criteria? I have ran the run book, everything is perfectly fine. And if that meets the criteria, it goes to security layer, right? Where you do, excuse me, where you do dynamic application security testing, right? Those of you who do not know what is dynamic application security testing, it is basically a black box testing where an external party or an external audit agency, you will invite them and say, hey, you do not have access to my code, internal codes, you have access to the external part of it. Like any end user behavior, you can perform any end user behavior which is dynamic in nature, and you can do the assessment of my application, right? You can do the review of the application, you can find bugs, right? For example, bug bounties are there, right? Third party black box testers are there, external pen testers are there. So these guys will come and do dynamic application security testing. If it is an internal organization, employees internally, you have access to code, then you can do static in nature, right? You already know what you have written, you already know which layers you have written, which is from previous build release, what new lines of code that you need to test, what codes will communicate to API, what codes will talk to payment gateway, what codes will talk to my social networking platform. So you already know. So therefore, a static application security testing is enough for you. But people who does not know how it is done, and you're inviting an external auditors, they would need dynamic application security testing as an approach there, right? Now the next wave, the next wave of dynamic application security testing is interactive application security testing, right? So it's a combination of static and dynamic put together. It's interactive, where an internal team, without having a pen testers onboarded, an internal developer can also run interactive tests and he will get the feedback. And therefore you're some way or the other, you're grooming the developer to do a security job here, right? So this is another way. And for an operational guys, the operational guys, you have security event and incident management tool. So with the SIM, what you can do is you can monitor the overall infrastructure, all the endpoints, collect those logs, do intelligence on top of it. Then you have runtime application security that you can also use in the runtime itself. Let's say you have a code package, you have a Java runtime that is supporting it, or a .NET runtime. You can also see any injections that are happening in the runtime here, right? So from an infrastructure, from a middleware, and from the application itself at different layers, you can analyze and see what are the security breach that are there, right? So where do you start from? If you're beginning, if you're starting now, or if you're a developer, if you're an infrastructure guy who's supporting some kind of an infrastructure today, and you want to shift left, get into security and then development, right? So let me tell you this: if you're an infrastructure guy doesn't know how to write a code, don't worry. DevOps is also for you. You always have operational role there, you always have security role there. You need to back up the codes, right? You need to make sure the underlying environment is running. Security credentials such as VPN setups, WAF setups, all this you still have to do. Your jobs are still relevant. All you have to do is learn the process, learn the tool, and become relevant, right? And likewise for our developers, do not get scared that you have to do now an infrastructure job, set up servers, things like that. You will complement operational guys by learning security and trying to adopt security from day one during your code writing experience. You can always bring in your security experience or learn security and incorporate from day one, and make sure that your codes are hygiene and secure, right? So this list is for both of you. If you're from an infrastructure or a development background, you can download this static application security testing tool. It is open source, it is freely available. If you have access to some GitHub repository, some open source code that is available, you can download that. You can run this tool and you can get the insights. It will tell you how many vulnerabilities that it has identified, how many bugs it has, what problem it has, what it failed, what it could not read, is a code encrypted, how old the code it is, what is the code version. All this information you can quickly learn yourself, right? And specifically for a developer guys, if you want to expand your existing CI/CD pipeline process, where you want to introduce code scanning from day one, you can use SCA software, composition analytics. This is also an open source tool that you can download and you can incorporate. If you have already familiarized with static tool and some amount of DevOps work that you have done, you're familiar with pen testing, then you can use dynamic application security testing. That will help you out to understand the application from outside. You can run this on Amazon.com or Google.com or any other website that is publicly hosted, and you can be a part of their bounty program. You can find bugs, problem, you can go back and report them and then get rewarded, right? So this will be the clear starting journey who are attending this webinar today, who wants to personally benefit themselves, or maybe want to use this tool within your organization and groom your teammates. So what to do next, right? Security testing, security test automation, pen testing, threat analysis, and infrastructure analytics, scanning, and testing. So these are the 4 or 5 areas that you need to be aware of, that you need to look into. If you're from an infrastructure background, then you can do vulnerability and pen testing of the infrastructure, of the network, of the operating system. You can follow CIS benchmarks. You can do all of this if you want to start from infrastructure side. If you're from a security testing site, then you can, if you're an infrastructure security, then you can use SIM tool, SOAR tool, data leak prevention. There are half a dozen tools that are there, both proprietary and open source, that you can use. You can play on the infrastructure side. From a middleware and application side, you can use SCA. You can use dynamic application and security testing, or you can use static also there. And then you can use some plugins that are available for Jenkins that you can incorporate. You can start from there. So if you are already using all of these tools, you're already champion some DevOps process and some security that you're already using in your organization, it is time that you up your game, right? So do away from the traditional way of doing it. Embrace the new capabilities and new practice that are coming in. So one being replacement of static application security testing and dynamic application security testing can now be replaced with interactive application security testing. Basically, it's a combination of both, where an internal organization can use this without a pen tester, and they can interact with the code itself like a real user and get this behavior, and then they can go back and address this problem. So this is the best way of doing that. Newly introduced runtime application self-protection build. So when developers are building the code within the runtime, they can embed a call code within that so that you can start monitoring from the runtime itself. And this is important when you have an environment where you do not have access to the infrastructure. One such example is serverless, Lambda, right? Or any Azure function. So you do not have an underlying infrastructure, but you have access to runtime. You can put your runtime there, and then you can run your code on top of it. Or if you have microservices environment where you do not have a full infrastructure but just a container itself, there also you can plug in this real-time application self-protection. This will ensure that you can capture the runtime behavior of that environment, right? And then hybrid. So if you have an external agency who's also working with you, and there's an internal pen testing team also that you have, then you can use a combination of DAS and AS, dynamic application security testing and interactive application security testing. And then you can achieve more, you can identify more security vulnerabilities, more risks in the code, and you can try to solve that problem. Operational security, guys, from an infrastructure background, 4 common things that you need to do. Make sure that there's a SIM tool that is there, right? There's an open source Elastic Kibana stacks that you get that you can use, or you can use Azure Sentinel, AWS Data Guard. There's a lot of tools that are there that you can use to secure your overall infrastructure. And then you can do vulnerability testing, right? If you're using AWS, you can use AWS Inspector. If you're using Azure, you can use Security Center, where you can do the analysis of the overall infrastructure, see what patches you have to do on an OS, what bug fixes that you have to do there, what security ports are open, right? All that you can do. You can make sure that your drives are encrypted, right, where your codes are stored, and data encryption in all network channels. You can have an SSL certificate and some kind of a key exchange that will authenticate and allow you to access the environment. So all these operational security best practices, make sure that you incorporate. So this is a secure practice that I believe, or an industry believe, that we way ahead. And so basically what we're doing is we're not only shifting security to the left, but we're also making sure that security is put as a checkpoint, as a controller against each stage, right? So think of it that you buy a mobile phone, right? And the company says the mobile phone, you have a warranty of 1 or 2 years, but typically the phone will last for 4 to 5 years. So what they have done is there's a quality check process at each stage to ensure that only quality parts and qualified components are put together at each stage. And if that one particular stage is skipped, there may be a faulty part that is plugged into your phone, right? So something like that, keeping that as an analogy in your mind, you see the whole assembly line that is built. You will start with the requirement, you do threat analysis, you see what is a trending threat that is there in the internet today against Google Go, or against Python, against Ruby on Rails, or whatever the development technology that you're using, and the middleware on which you will run this, and the operating system on which this will run, and on with what database. So you kind of try to see the threat intelligence and make sure that I'm not using the older version of anything, or I'm using the version that is not vulnerable at all, right? So you identify that, and then you start writing your codes, and there's a frequent QA process that happens. Even before it checks in, you try to see, okay, are my codes are meeting standard? So in my previous example, I told you the codes that are being tested and clean can be reused again and again. If you take a modular code writing approach, most of the time you don't have to write it because you've already written it. You can just copy paste and complete the code, right? So code review process there, and then you check in, and then you do static application security testing there. And once that is passed, you do a unit testing, and then you do a deployment testing, right? In the deployment testing, you will ensure that the code scans are run periodically, and then you do dynamic testing, and then you do interactive testing, right? And then you deploy this code to the stage. So from UAT, it has now reached to staging stage, and from stage, there's an acceptance test happens, and then it gets to pre-prod. So in pre-prod, I will do runtime test, right? Self-protection runtime test that I will do. And then I will also do a SIM tool to make sure that it is not making any outside call, the package that I have installed, or is not sharing any information. I will do that. And then I will do pen testing, and then I will deploy into production. So if you see here, there are several security checks that I have put into place from the time the code is checked in, from the time it moves to unit test, functional testing, staging, then pre-prod and prod, right? So this will ensure that if anything fails in staging, it can go back and start over again. You don't have to complete the complete cycle. You don't have to come back to production and then realize and go back. You can mitigate that, and you can do a damage control at mid stage itself. So one example that I thought you will be interested in, injecting security in DevOps, right? So this is a further more detailed view for you, and those of you who come from a DevOps background can clearly understand what I'm trying to depict. Guys from an infrastructure background, a quick summary here. On the left-hand side, a developer is there, right? He pre-commits a hook. So when I say pre-commits a hook, he is making an API call with a payment gateway, or making an API call to a social platform, or making an API call from your system's ERP. Just an example that I'm giving, some kind of a call that he's making. And this call will happen over an SSL, but this call to pass, an authentication has to happen. A username, password, or a secret key, access key has to happen. So what developer has done is he's hard-coded that information, the access key and secret key, for sending bulk emails, for sending SMS confirmation, or to go to ERP and collect some product information, right? Or talk to social platform to log in or get social profile, whatever that may be. He has hard-coded the credentials into the system. So the moment he commits that with the secret, the code repository has a secret management service. So you're trying to create a procedure there, a code management procedure there, which will go through several checklists, right? The checklist says, okay, has he stored username and password there? Yes or no? Is there any other sensitive information? Are you calling customer information? Is there any email ID or anything else that the developer has hard coded into that information? It will check. Is there a phone number or something? That information it will check. Is there a social security number or an Emirates ID information that is hard coded there, right? All the security checks that you will do, right? And make sure that if the check passes, it will go forward, right? And then you will do further static application security, where you will see what are the regs, what are the uncompleted codes, what are the codes that are open, right? Open syntax, all this you'll try to check there. And then when it goes to post build, if you see in pre-build and post-build, I'm doing a vulnerability management. Both way I'm doing a vulnerability management to see, has any vulnerability accidentally coming into the code. That is what I'm trying to do here, right? And then I will put this artifacts into my version control. I'll commit that. I'll keep version 1, 1.1, 1.2, right? And then when I'm redeploying again in QA staging, I'll go through another vulnerability testing, where I'll do manual web application penetration testing, right? And logic flows, I will try to check that all logics are correct. If I click on this button, it is going to the product page, right? If I'm clicking there, it is going to my payment page. All that flows I will check, and then I will roll this into production. Another example, so this is how a new assembly line would look like. A typical DevOps assembly line in the top is fairly straightforward. There's no security layers that are there. But in the bottom, if you see in DevOps security, you can see there is a static application security testing that I'm doing over here. And then I'm doing a dynamic over here. Code scans I'm doing over here, and I'm doing a firewall. After the firewall, it is end. So this is how a new pipeline would look like. So cultural mindset, guys, I have already told you, you need to bring culture, you need to bring process, you need to bring new tools. A team has to be trained. A security AB has to be introduced from day one. So a cultural shift is required, and I'm pretty sure after this you will start talking about security shifting to left, starting security along with the development, and how to implement DevSecOps, right? So benefits, faster, right? You can quickly detect vulnerabilities and mitigate that early. The posture of your security is always right? You will not be reactive, oh my god, what happened, versus okay, I know what is happening, let me correct it. So this kind of an attitude has to bring in, right? No or less security risk, right? For example, let's say a page is broken and somebody got in and changed the photo on your website. Okay, you can go back and correct it. But a payment gateway link is broken, somebody is cashing in money, that is not okay, right? So try to mitigate purity risks first, and then try to have a cleaner code, less complicated code, and less vulnerable code, so that any exposures happens, you can go back and mitigate that, right? um, Cost of fixing is high, because see, if from an organization point of view, if a code can be developed in 45 days, right, versus 60 days, that means 3 months salary they have to pay for a development people just to develop the same code. But if they develop this code in 1 month, within first month salary, the whole development is just an example that I'm giving you. So in a long development cycles, let's say if development is taking 2 years versus 6 months, if a company could develop a code, a quality code, a secure code, a clean code in 6 months, with just a 6 month salary, they are able to develop all this, right? Instead of spending 2 years salary there. So one advantage there, avoid publicity for getting pond. So pond is basically somebody has control over you or has your data, right? So you don't want that to happen. So all these areas that you need to keep in mind, and DevSecOps process, if you follow, you will mitigate all this. These are the benefits that you will get, right? And quickly, I will talk about serverless also, right? I've been getting messages that we have to be open for a Q&A session. So I will talk about serverless. So people might think, what is there to why should we worry about DevOps security on serverless? Because the entire environment is built and managed by the cloud provider themselves. So what security problems that we will have? It is serverless in nature, right? So let's try to break this myth and understand what breaches could happen in the serverless environment and how this will impact your business. So a typical cloud provider, if you see the environment here, they can only manage your environment up to virtualization, up to containerization, right? But after that, you have to take care of client side data transit, the application functions that you write, identity and access management, configurations, all that is our responsibility. We have to take care of that. Now, when it is not taken care properly, what is the impact is what we will learn, right? So in the traditional protection, there are so many things that you have. There's so many layers that you can bring it in. You can bring in a web application firewall where you can make sure that only allowed traffic can come. Any unexpected traffic that I'm receiving from China, I can block that IP. I can put DDoS there, right? Just an example that I'm giving you. So web application firewall is there to ensure that the first layer of protection it will take care, right? The network firewall, I will make sure that only VPN traffic can go to database, but any traffic that is coming from an application server should not reach my database, right? Except the application itself, right? Over JDBC, ODBC, whatever driver protocol that you call, right? And then outbound traffic, what information can be sent out, right? That also you can restrict so that nobody is downloading your codes or nobody is downloading your artifacts or customer information. Those things also you can protect, right? Intrusion prevention systems you can built in, right? Machine learning and AI based prevention systems will see anomalies, unusual behaviors, and try to prevent it automatically, right? So those things you will take care of it, right? Application EPP behaviors also so holistically, traditionally, if you're looking at, there is so much that is matured and available in the market that you can secure your application. But what is it for serverless, right? Now, if you see from a cloud provider's perspective here, today, if you take an infrastructure as a service, two things the cloud provider does: physical infrastructure they will give, and till virtualization they will secure it. But everything else that we need to manage it. That is a typical monolithic approach that we are looking, and that is why they're fading away, because there's so much work an end customer has to do, right? And hence they're kind of shifting away to serverless, because serverless means you don't have to do all of this, right? You don't have to do log management, you don't have to do patch updates, you don't have to worry about securing configuration, you don't have to worry about network OS hardening. All this you don't have to do in serverless, right? But what is it that you have to do in serverless? Let's try to figure out. So in serverless, you have to take care of authenticating users, what users are coming in, what users are accessing. This is very important. Second thing is log and maintenance of audit, what came in, what came out, what changes have happened. These all you have to take care of it. And then data leak prevention you have to do. I cannot just invoke a function and I cannot export a data. I have to also make sure that all type of data leak preventions are taken care of, right? And vulnerabilities, the code has vulnerability. Remember, we're talking about AppSec, not InfraSec. So the code will have a vulnerability on which you have to worry about. Those all you have to take care, right? So these are the 10 top problems last month that has been identified. that has happened through serverless. I can invoke a function, right? I can execute a function and I can tell serverless to do certain things, right? I can invoke a function, say export XYZ customer data and email me. This I can invoke in serverless. This is the biggest breach and known breach that is there. Authentication is broken. So basically you give permission all, or permissions are open, anybody can hack. For example, admin username and password, something like that. So people can get into there. Insecure serverless deployment if your codes are not encrypted, right? That is one. Overprivileged functional permission. So I will say everybody are administrator in the team. So there is no hierarchy, there's no RBAC, right? Inadvocate, this you're not monitoring at all. So there's no monitoring that is happening, right? Financial intrusion. This is the biggest ask that customers are worried about, that a lot of people are hitting a lot of unnecessary traffic on my serverless application. The meaningful traffic is, let's say, only 5%, 95%. I only get unnecessary traffic on my site. My Lambda does not know that and continue to scale up, or Azure function does not know that, it will continue to scale up, and therefore Azure or AWS is charging me. So there's a huge implications from an financial exhaustions that you will have. So you want to prevent doing all of this, right? So couple of more things. I'm running out of time. So those of you who are interested, you can take a screenshot, take a print. So these are all the dev security and operation tools that are natively available. There's a conventional tools that you can use, you can implement if it is a non-premise, if you're doing it on a cloud, list of tools that are already available here that you can get started today. So a quick wrap up here, right? If you're starting up, then you can start with the static analytics to a static application security tool and dynamic from an application perspective. If you're an infrastructure guy, start with SIM, right? And then security center, denial of services. So there are a lot of tools that are available. You can start with that, and you can come closer to DevSecOps, right? A case study. So I would not disclose an organization name, but an overview. This organization specializes in writing and developing code, and they've been doing it for the last 10, 15 years. They're great at what they do, right? But there were two problems. The first problem was that it was taking longer time for them to write the code. And by the time the code is written and come back, it was further taking longer for them to test and come. So there was no loop there. So the loop had to be introduced, right? Second thing is the applications that they had were mostly legacy in nature, and most customers were asking for new application. They wanted to modernize that. So therefore, they thought DevOps was the ideal way of doing it. And then they realized putting security will also ensure that it will be ready, right? And third thing is time. They significantly wanted to give upgrades and updates to their end customers from legacy application to new application. And predominantly most of the applications are standard in nature, but there are certain features that are tailored to respective customer A, B, and C. So they wanted to also make sure that they cater to that customer in the same cycle. So the outcome of this results are this, right? So they quickly improved, they quickly found bugs that were there in legacy code when they were doing an application modernization. That was 74%. Quality of the code was improved. They were able to quickly mitigate the packages in between. They started with clean code, did not deploy on third-party packages, right? So a lot of best practices that they have done, and they have completely done away with what you call for last 10, 15 years, the accumulation that they never used, that was cleaned off in the process here. So as a 3i, we have strong expertise, understanding, we understand tool. I mean, I have not completely articulated everything because I have a very strong constraint in terms of timing, but I would like to definitely meet you one-on-one or maybe a WebEx and try to understand how we can help you out, or if you need any information tools, I can recommend you, I can guide you through, or we can work together and help you out to achieve more. We have a lifecycle management services that we offer, where we help you out to manage your overall infrastructure, manage your DevOps process, and also help you out to guide from time to time the direction to take. All that we will do from end to end. We have our own tools, we have our own process and procedures that we bring in, and we will give it to you and work with you. So why 3i Infotech? We have a strong pool of talents here, and we have hundreds of customers that we have implemented this. So this is not a learning bit for us. We have already learned, we have already matured, we already know these things very well. We are very flexible to work with at various price range, various customer sizes. We can work with you. And then we can tell you the benefits of flexibility on the cloud, because cloud is dynamic in nature from a billing perspective. We can help you manage, we can bring significant costs down there. We can also guide you and do consulting service in setting up your own DevOps and reduce significant costs there, help you out with our own skill sets, and also help you out to get skill sets from the market. All of that we can do. We're very uniquely positioned here. So with that said, I thank you very much, guys, for listening to me. I had to rush in last minute, but we started late. So I'm open for any Q&A, and then we will take it from there.
So much, Sohail. Thank you 3 times for that. Such a wonderful webinar. I look forward for more such. Thank you, audience, for joining.